So the second significance and importance of our corrosion is milling equipment. Most of the times milling equipment is containing one rotating element. So that rotating element is making the movement of balls or hammer or anything which is going to cause a friction. That friction is going to get affected, your equipment part causes the corrosion and makes the contamination of that particular material of plant construction as a contaminating into the equipment. Chemical processing reactors, most of the times in the bulk drug manufacture, they are going to have a exposure to so many chemicals. These chemicals are going to damage our equipment surface, make the contamination. So this is actually chemical processing reactors which are used in the bulk drug manufacture getting damaged because of the corrosion. Another one is the fermenters used in the biotechnology. Now we are seeing in the COVID, we are manufacturing vaccines and supplying to the entire world. There we are going to use a fermenter by creating temperature and oxygen levels, and we are going to have a stirring and retaining in a closed manner. By after incubation, we are going to have some of the growth of our antibodies, or it may be antigens, or maybe desired product. Then we are making them extracted. In this phenomena, we are going to use the oxygen. We know that oxygen is more prone to give the corrosion effects. Similarly, we are going to use most of the times your product is going to inoculated with some microorganisms. We have already seen that microbial corrosion, where microorganism able to make the product converted into inactive species into the active and electrolyte. So they are going to have a more corrosion prone environment. So in those cases also we are going to have this corrosion problem. Most of the times we are using the concept called as glass lined vessels, so that we will be preventing exposure of these media for the longer period of the incubation by putting a glass coating over to that. So this is the way we are finding the significance and importance of them and trying the factors which is affecting. Accordingly, we are putting a preventive measure to it. So we will see later. Certainly our storage containers are bound to be getting attacked with corrosion. This is the reason we are going to see the number of matter is there, and it is easy to understand also. The first factor that influences the corrosion is nature of metal. So the nature of the metal is prime factor in the corrosion. In this particular case, the metal which is having a more active in nature is going to more prone to get corrosion. So this is actually what the nature of the metal is. The purity of the metal. The purity of the metal is the one which is having greater impact, because a metal is having an impurity. That impurity is having certainly an extent which is going to be corroded more prone to that actual metal. The actual metal what we have studied is having a corrosion protection and inactive, but the impurity is very active and prone to get corrosion. So it causes the pitting corrosion. The pitting may be expanded further, deepened, and it will be converting it to a crack, break, and leak. So this type of problem will be going to occur. So in this particular case, we are going to select a correct material and with greatest purity without having any contamination or impurity in the structure of the particular material we are selecting. The third parameter is physical state of the metal. Of course, at variations in the temperatures, the physical state of the metal is going to be varied. We cannot overheat aluminum when compared to your stainless steel. So remaining, you are having further like a gold and platinum, you can expose it to the highest temperatures also. So the physical state of the metal will be varying with the temperature of exposure. So we need to select the material in such a way that what is its coefficient of expansion and changes in the form and the shape and the size of that particular vessel. Position of the metal in the galvanic series. What is the position of that particular metal in the galvanic series, where either it is a active or inactive? If it is active, it is going to act as an anode and it is getting corroded. So it is not worth to take that particular highly active metal so that it is going to get corroded. That is the reason we are going to put any preventive measures in those cases if it is unavoidable. Nature of the products of the corrosion. most of the times what will happen, your corrosion product is soluble in nature, they will be acting as a impurity into your output. So that is the reason we are going to see the nature of the product, whether it is a toxic or not, whether the product which is having a entering into the contamination, which is going to act as a catalyst in our reaction or not. So the nature and the utility of the product of the corrosion is going to decide whether I can proceed with it or not. Similarly, the solubility of the products of the corrosion is more, and you are going to have a more and more damage. If the product of corrosion is insoluble, even it acts as a preventive measure for the corrosion by acting as a coating. Similarly, you have got another point, relative areas of cathode and anode. We know that anode is more prone to get corrosion. So the points what you are watching now is more prone to get in GPAT. These are all the concept oriented points. So when you have been asked the which is when compared to a cathode and anode, which is going to be getting corroded first, obviously it is anode, because there the oxidation reaction is going on. Because of that, you are, you are going to get charged species. Nature of the corroding environment, one is temperature, another one is humidity. So the temperature and the humidity are going to have a very high prone to get corrosion. In those environment, any equipment is going to get damaged very fast. Because of wetting, corrosion is more prone in humidity. Temperature is more supporting for the progression of reaction, because we know that corrosion is physicochemical and electrochemical reaction. So temperature is already going to have a better, more prone get effect on the corrosion. Effect of pH. Most of the times, pH, extremes of the pH has got very bad impact onto the corrosion of the equipment. So highly acidic pH and highly basic pH approaching to 14 or 1, they are more damaging and going to cause the corrosion when compared to neutral pH. In the neutral pH of the 7, when your environment is set and your reaction mixture is present, your corrosion is going to be very less. It means that whenever we are using the extreme pHs in reaction, we need to see that how to prevent the corrosion in that particular reaction equipment. Presence of impurities in the atmosphere, like fumes and the dust, which are going to be fallen onto the equipment, makes the corrosion progressive, which will be tend to make a pitting corrosion by even providing enough environment by attracting the moisture and depositing those fumes and dust, and in the areas where it is present, they will be acting as a crevices and acting as a oxygen concentration cells and making the corrosion progressive. And most of the times these dust, they tend to absorb the corrosive materials, and they will be keeping in the place for longer period of the time and making it to get corroded. That is the reason we are going to do the de-dusting of our equipment, covering of our equipment after cleaning, in order to avoid this problem. Not only that, in our home, if you see it, your vehicles or anything which you are going to protect after cleaning, and after coming from the garage, you are covering with some packaging material, cover sheet, so that you will be having this prevention of that. Otherwise, your surface of that particular finish will be going. Nature of the electrolyte. Most of the times, the nature of electrolytes is monovalent. It bound to get a dissolution very prone when compared to tetravalent and trivalent electrolytes. When the case of more valency of the electrolytes which is formed, they will be acting as a barriers and they prevent the corrosion. And the corrosion product is less homologous series of a monovalent electrolytes. They will be dissolving it and causes the progression of the corrosion. Another one is nature of oxide film. If the oxide film has got anything which is the nature which is having, so the oxide film is having insoluble in nature, that will be acting as a coating, and the coating will be having a protection effect. So in the reverse, if the oxide film is having a soluble in nature, then it will be having a progression effect, because it is going to get depleted from the surface and again progressing the corrosion. Whereas insoluble product, it will prevent the exposure of that particular part to the environment as acting as a barrier and reduce the corrosion. So you need to understand all these factors, and if you have been asked the question for the factors influence corrosion in the 2 marks question, just at least you write 8 factors and list them. If you have been asked, you write all of them in the 5 marks question, and a little bit elaboration for each sentence is required. If it is been given as in 10 marks, you need to write all of them and explain all the factors in detail. So according to your weightage of answers and the question marks, you are going to decide how much matter I need to write in this particular question. Okay, now we are going to enter into further our topic is, which is very, very important and most probable, is prevention and control of corrosion. So we have already seen the factors and we have discussed, we have seen the types, and we know that how it is going to happen. Now we are going to see the prevention and control of the corrosion. So coating of the metal. Coating of the metal is the one which we are going to have better barrier effect in order to prevent the corrosion, because the resistant coating is made between the metal and the environment by the application of a paint or oxide layer itself, and we are putting a layer of another metal, so which is having a barrier effect. So this is one way we are going to prevent our corrosion. Another one is alloy of the metal. Alloying of a metal is very important. If you are having that a parent metal has got more prone to get a corrosion, and it is going to be very active. So we are going to convert that particular parent metal into alloy by adding another materials at certain proportions. By mixing them, they will be having enough bondages and makes the another metal less active. This is the concept of alloying. Any alloy is divided into 2 types. One is a homogeneous alloy, another is a heterogeneous alloy. Heterogeneous alloy is just like your compound resistance in the series. A layers of and mixture of the 2 or more separate phases are present. In that you don't get any solid solution, and you are getting a separate layer as a each metal. So you are going to get intergranular corrosion. That is the reason heterogeneous alloys are not good in our pharmaceutical industry. It is better to make homogeneous alloy, in that solid solutions are formed where each metal is getting distributed into the another metal and making it completely soluble in one another, making it possible. This is actually what the concept called as homogeneous and heterogeneous alloys. It means that a solid solution or homogeneous alloys are more corrosion resistant. For example, when you are mixing a chromium in the iron, you are going to get a steel of a particular grade that is going to have a better resistance to the corrosion. So we need to select in our market what are the alloys which are present, which is having a more corrosion resistant. If we are putting them as our material of construction, by paying a little bit more cost to our capital expenditure, we can prevent the corrosion progression. So this decision we are going to take it when we are commissioning our factory and installing new equipment. So due requirement is taken into the consideration. What is the exposure of my equipment with what pH and temperature conditions and humidity or water I am going to expose it or not. Accordingly, this selection of the material is very much crucial. This part is already present in the second portion of this particular unit. So you are going to have and select the material among so many things which are available to us depending upon this factor. Obviously, silicon is also used to making a alloy with iron, so to have a corrosion resistant. Even it will cause some of the resistance to the corrosive substances like acids. So you can handle them with due care by mixing with silicon also. Because it is a cheaper, it will make the product cheaper, but at the same time you are going to have a corrosion resistant vessel. But we need to look into the fragility also into the account. That is a different part. So one methodology approach what we have previously seen is alloying of material, coating of material we have seen, and obviously design of that particular equipment is going to help us, because that design which is having any crevices or the enclosures or the stagnancy of our particular reaction mixture, corrosion mixture, it is going to get a damaging effects onto the equipment. That is the reason we are going to take these factors. In addition to that, there is some scientific approaches to make our corrosion prevention. This notes of this is present in the book which is already been given to you. So you can see it after this particular class and just read once, and you are going to register in the brain, because this is very important for your both examinations. Another important parameter is which you are going to prevent corrosion and control the corrosion is sacrificial protection. In the sacrificial protection, we sacrifice one metal in the another metal of the equipment, so that the parent metal of the equipment will be protected, and the added sacrificed metal is getting degraded and getting corroded. So in this case, the surface of the iron is covered with more electropositive metal like zinc or aluminum. So that will get corroded first when compared to the regular metal what we are going to use it. So that will, in that way, we can make our corrosion prevented by applying a layer over it. Since this metal loses electrons more readily than iron, rusting is prevented. Most of the times this metal loses the electron and more readily when compared to iron. If you don't put this particular layer, what will happen? The iron will be getting attacked, even it is a single metal, by the single metal corrosion. So this is actually the concept of sacrificial protection. As long as this particular metal is present as a coating, so you don't have any problem to the parent metal, so you are going to escape from the corrosion. This is actually what is an example for the sacrificial protection. Another one is cathodic protection. In the cathodic protection of the parent metal from the corrosion by connecting with a more active metal to it in the form of a rods or bars, and sometimes they will be kept inside the mixture, or sometimes it will be earthed into the ground. So this will happen. What is a good thing in it? Most of the times when the corrosion effects are progressing, and this metal what we have kept as a bar or electrode is going to be getting degraded first. So example like aluminum, zinc and magnesium, these bars, so they will be more prone to get corroded to the when compared to a parent metal. If these components are going to get contaminated our product, so then we should not insert these bars inside our reaction mixture. We need to keep them outside. So in this way we can prevent also. Sometimes we require this component to be added as a salts into our product. It is better to put inside the mixture, so that we will be having the advantage of putting that salts also as a component in our product. So this metallic container will be protected is connecting with a more active metal. So that is actually called as a sacrificial anode, so that we will be protecting a cathode. This is the way previously what we have done as a coating. In this case, we have got a replaceable bars. Previously it is a coating, it is applied as a layer onto the surface of the vessel. Now we are keeping it as a bars, so that when the bar is completely getting dissolved, just we can replace it with another bar. So this is actually what that going to give a cathodic protection. So the connected metal undergoes the corrosion, thereby protecting parent metal. Another one is impressed EMF method. In the impressed EMF method, we know that electrochemical corrosion or the galvanic corrosion, which is going to be having in our pharmaceutical industry, which is caused by the flow of electrons. When the flow of electrons are present, they are getting depleted by the formation of reduction reaction in the cathode, and we are going to make the corrosion progression. So in order to avoid it, what we will do, instead of creating an electricity and making a degradation of anode, we supply the electricity directly to anode, so that we will be depleting the reaction environment. So there is no progression of electrons. So in previous case, without having impressed EMF method, electron flow will be present from anode to cathode. Now we are giving an impulse that is impressing the electromotive force, so that causes the negative charge which is not going to be traveled towards the cathode. So this corrosion will be prevented. So this is actually one approach. It will be applying by the proactively we are making it to not to degrade. But the problem in this particular case, you can get electric shock because we are giving a current to our equipment. So that may cause the electrocution when if anybody is touching it. So in those cases, you can put a barrier and you can put enclosure, or it may be kept in the room and nobody is allowed to that room till the our work is progressing it. After that, we can remove it and wash it again. You can keep it for the next usage. This is the way we can use impressed EMF method for the prevention of the corrosion. But in this particular case, what we have got the problem and disadvantage is that electric shock we are going to get it when the equipment is getting connected by the electricity. Other purpose, what you do, we will be finding in R&D a passivating potential and passivating current. So what is this passivating potential and current? You take a 2 bars of any unknown metals, let them connected in the electrochemical reaction by the galvanic cell concept by putting them in the electrolyte solution, that is acidic dilute acidic solution, and giving a connection. You bound to get some electricity generated that you can be noting by putting ammeter and voltmeter. How much is the voltage which is generated in that particular combination, we will be able to know it. It means this much of current is bound to be present when the reaction is progressing for corrosion. Instead of applying too much of current there and getting a electric shock, you apply that minimal potential and the current supply to that particular galvanic cell. So you can get the advantage of your getting protection. At the same time, you are going to have the prevention of the corrosion and not having any electric shock. This is actually called as a passivization current and potential application to make the anode protected. So in this particular case, what we are going to do, first we are finding out how much is the potential it is generated, and electric current is going to be moved in milliamperes, and such much current we are going to apply to anode so that your prevention will be there. So I hope you understood this concept. Around 7 factors are present, including your design, coatings, and you have got cathodic protection, anodic protection, sacrificial protection. So this makes the complete answer for 10 marks, and very, very important. Just you can see back the book which is already been given as a soft copy, and you can read it and understand it so that you will be having a better edge to write the examination. And I'm taking it to next level of learning extension. There are some courses are available in NPTEL and some of the open platform. So these are all the numbers and the links which I've already provided. If somebody is interested in having a further extension of learning and getting a certificate, so these links will be helping you in the summer vacation or any time. If you want to enroll these courses of IIT, they are creating, and they are very good courses. I have gone through it. You need not pay any money. Just you go to that particular course, enroll yourself by putting your email ID and credentials, and they will be releasing video lectures frequently every week. Just watch them and see what the written material they are supplying it, and then you can learn better. So these courses, it will give the better extension of learning if you are really want to go further depth in this particular very interesting topic. So this